Welcome everyone to this new lesson. In the previous one, we were talking about the emitters provided by RealFlow in Cinema 4D. We talked about them in general terms, and in future lessons, we'll be working with them in a practical exercise. In this lesson, we'll be looking to Daemons, which, as I said previously, introduce forces for accelerating and influencing particles and create really cool effects. The first daemon is the attractor, which we'll be using a lot. This emitter lets us attract the liquid to the object. Okay, so in this case, we have the emitter here, and I've included 3 attractors, which can be placed in different planes if we want to. So what happens? The liquid starts in this emitter and goes to the second attractor and then to the third one. See? The liquid goes to the first attractor since it's attracted by it, okay? Then it's attracted by the second one, and then the third one. The liquid doesn't reach the last attractor because of the current settings. If we alter the internal force parameter, the liquid's direction changes. Okay, but I think I'll leave it like that to keep the effect caused by the liquid colliding. This effect, okay? Guys, we'll work with all these parameters when doing the exercise, where we'll go deeply into each setting. What I'm going to do now is create simple animations using the cache in order to show you how each option works, okay? So the next daemon is the crown, which is also quite interesting. Let's have a look at it. Okay, the simulation is already cached, so we can see what happens. Let me give you a tip. When working with a crown daemon, it would be a good idea to combine it with a gravity daemon, since it lets us create splashes. Okay, so we have this box here. Remember that we can create any shape we want in the emitter type. Here we can select any shape. Okay. In this case, I've created a cube, and I'm going to make a ball fall into the liquid and then splash in. Okay. So this is the effect we are going to create right now, and we are going to use the crown for this. We cannot see the ball yet, but this is a kind of the effect I want to get. Okay. Let me show you how I'm going to do it. Make visible the crown. Okay, this daemon allows us to get this splash you see on the screen. Actually, there's no sphere generating the splash. There's no ball, okay? It is the crown daemon, the one that generates this effect. Perfect. The next one is the drag daemon, which is this one and simulates external air drag forces that slow down faster particles or bodies. Have a look at the following animations. You can see particles are moving. Okay? In addition, this animation has no gravity, so particles move everywhere freely. So in order to force particles' body to stop completely, we can increase the drag strength. Have a look now. The liquid doesn't move anymore since the particles are slowed down, okay? So this is what the drag daemon does. The next in order is the spline daemon. This daemon is similar to the spline emitter, which we saw previously, okay? But I prefer using it for creating these types of effects, and we'll be working with it later on. Okay? Okay, so guys, I've created this sort of spline. I've created this spline, but you can give it the shape you want. Then within the spline properties panel, we find a tab called Control, where we can use the different parameters to add circles like this on the screen, so that each of them attracts the liquid and it goes along the spline's shape. As you can see, the liquid starts from the bottom, okay? It's possible to browse through the individual control points and edit them separately in order to create a particular flow. So here, for instance, what I did was modify some specific parameters to get this curve over here, okay? It is, these circles don't have the same properties than the others, so the liquid follows the path created by the circles until reaching the end of the spline. The reason why we are going to practice with this daemon later is because it's a frequently used tool. Let's move on to the daemon filter, which is the next one. This daemon is used to swap particles from one fluid container to another and to separate them. So, it's necessary to have two fluids, a source and a target one, and both of them should have a similar or equal resolution to avoid instabilities, especially when they present different materials, okay? So we are going to use this daemon filter when we want different materials for each fluid. The next daemon is gravity, which is also really important. Okay, and this daemon is used to add gravity to the scene, something essential when working with liquid simulations. As in real life, gravity makes liquids and all objects on Earth to be attracted to the center of the planet. Obviously, this gravity can be modified. If we click on gravity in the scene tree, we'll be able to alter the strength. If we set it to a negative value, the gravity changes and the liquid goes upwards. For example, Moon's gravity would be different, okay? This daemon is really, really useful, especially when combined with other tools and effects. So that's why we are going to use this daemon a lot every time we work with other daemons or tools, okay? KH is the next daemon. As you can see, there are some of them starting with K in the list, okay? What does the K mean? Well, this daemon makes possible to remove particles when a time limit is reached. Let's say we had an animation of 300 frames, but the KH isn't activated, okay, and only the gravity is available, okay? The particles in this case would flow out constantly until reaching 300 frames, which would slow down the software functioning and the device in general. Okay, so the K daemons are great for controlling the particles. These are KH, K isolated, K speed, and K volume. Right? Let's go back to the KH. In this case, this daemon works with time limits. Activate it, and we can use the live parameter to set the particle's time. Let's say we want the animation to finish earlier. Okay? Have a look at the animation. As you can see, the liquid is generated, but in the first frames, particles disappear. If we increase the life value, the particles last longer, but they disappear at some point as well. If we set life at, I don't know, 0.4, only the beginning of the animation is simulated, see? So we can blow it up to see what happens with the particle simulation. So this is KH, which is based on particles' lifetime. Then we find others like K speed, K isolate, or K volume. And now we're going to select the K speed, which is based on the particle's velocity. This daemon can be used to delete particles using the speed. Then the K volume, which creates a scalable box like this one to delete particles from inside or outside the box. It's like it establishes some limits and then particles don't go through the box. Let's place it here, okay. Now if we go to fall off and activate the invert checkbox, when the liquid reaches the box, it disappears. See? It's like it doesn't go through it. However, if we uncheck it, it will happen the other way around. The liquid is only visible when it reaches the box. Okay? In this case, I'm going to keep it inverted since I prefer this effect. Okay? It's also possible to change the shape of the box here in shape. If we click here, I don't know, this one, it becomes a cylinder. The weight parameter can also be modified in order to control how the particles vanish. Okay? See the difference? So we can decide how the particles fall down, okay? The next in order is the Demon Magic. Let's open it. This demon turns an attached object into an attractor, as it happened with the attractor 1. The difference is that it pulls the particles towards its faces. The liquid would go around the object, okay? Let me display the animation I did previously. Here we have it. See? With this demon, the liquid is attracted by the attractor object. In this case, it's a sphere. And not only that, it also surrounds the object. Okay? And in the magic panel, we can tweak different parameters to get different effects. Okay, instead of the sphere, it could be another object and get a different animation, okay? Let's move on to the noise field. Open it. Well, guys, we're also going to use this demon a lot. This one generates a sort of noise. How is that? Well, liquid normally flows out downwards when the gravity is on, right? The noise function gives us extra realism by adding a random force field. See? The liquid flows out more realistic now. Here, as you can see, particles are randomly disturbed. It's more like a natural fluid, right? If we wouldn't use this demon, the liquid would flow out like uniformly, right? There wouldn't be randomness. As always, in the noise field panel, we find different parameters that can be modified, like the weight, scale, or even invert option. Let's move on to the demon shader. This one is used a lot, and I like to call it a complement demon. Let me explain how it works. When the liquid is generated, some holes appear as well. Like these you can see on the screen. So this demon's main purpose is to detect holes in particle fluids and fill them. See? It's like it fills the holes. Let's see what happens when the shader is disabled. Look at those holes. If we activate the demon, most of them are filled. You'll see that. See? The difference is huge, actually. So in order to enhance the results, we would need to tweak the parameters. It can also be used in combination with other demons if we want to. Okay, so this is its main function, okay? Then the demon surface tension. This demon enhances a fluid's tendency to accumulate and form drops. Let's uncheck it and initiate the animation so that you can see it clearly. The fluid is emitted and some kind of drops are created, but when enabling the surface tension, the effect is made more evident. It's also like a helper demon. Okay? The next in the list is the demon Vortex, which is also quite useful. And we are going to use it a lot as well. It creates a force field around the demon center and along its vertical axis. So by altering the different parameters, we can get these effects, okay? Let me show you the vortex. Okay, there it is. So apart from the vortex, I've added an attractor at the bottom. Okay, which is here. And I've added it so that the fluid doesn't go all over the scene and keep the liquid in this area. Okay, so I want the liquid to be in this area, so that's why I inserted an attractor, okay? Regarding these holes, which are generated here, later on we'll be working with the measures type and fluid and add different effects like the shader to fill the holes, okay? So with that demon, we would fill these holes. The last demon is the wind, which is used to simulate wind in the scene. So here is the fluid, and I've inserted a wind force along the Z axis. So depending on the strength and the velocity, the wind will affect the fluid differently, okay? Well, guys, so you can see there are many quite interesting and useful demons, which we've been talking about throughout this lesson. And, well, in the next video, we'll be having a look at the measure and the fluid. We've already seen some parameters, but we'll still need to learn how to improve the quality. That's why we'll be working with measures and fluids. Okay? I recommend that you create scenes with each demon to study them deeply when doing the exercise afterwards. So, again, practice with them, play around with the different options, and see you in the next lesson. Bye!